All right, in this final section of this unit, we're going to talk about naming cycloalkanes. We learned earlier that many alkanes can have a cyclic structure. The result is that they have one less hydrogen than the straight chain alkanes, and the prefix cyclo is added to the name. When substituents are added, there are some differences as compared to naming straight chain alkanes. First, since there is no end to the chain, if just one substituent is added, a number prefix can't be added since there's no end to the chain. So here's an example of this. This is named methylcyclohexane. It is hexane because the cyclic structure has 6 carbons. The prefix cyclo is added since it's a cyclic structure. That is preceded by methyl because it has a single methyl as a substituent here. No numerical prefix is needed since there's no numbering to the carbons if there is 0 or 1 substituent, right? So methylcyclohexane just has a single methyl group, and it doesn't matter what carbon you put it on. Any one of those carbons, if it had a single methyl group, would be the same structure. When we add a second substituent, so you can see in this case we've added an ethyl group, the behavior of the compound will depend on the relative location of the 2 substituents, so we do need to add numbering. The number 1 carbon is determined by a list of priorities. In this case, it is done alphabetically. So we have a methyl group and an ethyl group. So in this case, the ethyl is at the number 1 carbon, which you can see in the diagram indicated by that purple number 1. All right, so once I know that this ethyl substituent starts my carbon number 1, the methyl's location is determined by counting in the direction which will yield the lowest number. So I could have done my counting in the opposite direction, clockwise. I could have said 1, 2, 3, 4, 5, 6, but then this methyl would be on carbon 6, and that's not the lowest number. So instead I go counterclockwise and I say 1, 2, 3, 4, 5, 6. Okay? The name of this compound then is 1-ethyl 2-methyl cyclohexane. All right, here's example 1. We can see our cyclic structure, and the first step is just to identify and name the alkane, or in this case, our ring structure. So we just need to count how many carbons are in the ring. We're not going to number it yet. We're just going to count how many are there. So we have 1, 2, 3, 4, 5 carbons in this ring structure. So we're going to call this cyclopentane. Cyclopentane. Once we've identified our ring structure, we need to identify our substituents. So there are 2. There's a methyl group here that I've circled in red, and I'll switch to blue. Down here, this is 2 carbons, 1, 2, so that's an ethyl group. So we have a methyl group and an ethyl group. All right, finally we need to number the carbons, and we start in alphabetical order. We'll start at the ethyl group, so that'll be number 1. Now we have to go in the direction so that the methyl group has the lowest number. So if I go clockwise, then this would be carbon 2, carbon 3, carbon 4, carbon 5. Had I gone counterclockwise, then I would get 2, 3, 4. This would have been carbon 4 instead of carbon 3, and that's not the lowest number. So we have we have clockwise our correct number of that cyclopentane. Once we've numbered our cycloalkane, we just have to write the name. So we have 1-ethyl, 3-methyl, cyclopentane. 1-ethyl, 3-methyl, cyclopentane. And actually, we don't need the space here. That can just be one word. Okay, so there's our name. All right, on this slide, we see a summary of everything we did in example 1, where we named the cycloalkane, identified the substituents, numbered based on the numbering rules, and then finally wrote the name of the molecule, 1-ethyl 3-methyl cyclopentane.